Hammer mill. Hammer mill works on the principle of impact. Impact, as we discussed, this is nothing but hitting of the materials with strong metallic rods or hammers. This hammer mill exactly work on the same principle, and let us look into the construction of hammer mill. Hammer mills are made up generally of hardened steel and stainless steel because they need quite good strength and they should be stubborn, and the impact surface, the surface of the hammers as well as the inner surface of the chamber are usually prepared with hastellite or carbonite for stronger surface properties. So this is the milling chamber, you can see, and inside the milling chamber there is a rotor which is circular, and there are various hammers attached to it. Okay, the entire assembly is attached to a shaft. The shaft is connected to a motor and it will rotate. So this here is the feed hopper. The feed comes over here and there is a screw controller for the feed. You can adjust the rate of feed entering into the milling chamber over here, and further the size reduction will take place in the milling chamber by impact, and small particles which are already size reduced will pass through the screen and come into the receiver. So this is how a hammer mill is going to produce smaller particles from coarse and non-uniform particles. So the bars used in the hammer can be, the hammers can be in different shapes. They can be a bar shape hammer or stirrup hammers, and again the hammers may be either rigid or swing type that they can freely move on the axis. This will increase the clearance between hammer and the screen, and they can also have flat edges or sometimes sharp edges. So the hammers are of varying sizes, shapes and types, and the working of hammer mill, as we already discussed, they rotate in a high speed of 8000 to 15,000 rpm, and the fineness, how small the particles can be that obtained from the hammer mill, depends on several factors as follows. They are nothing but rotor speed, feed rate, clearance between hammers and grinding plates, then the number and types of hammers and size of the screen. So there are several factors which can decide the size of the product comes out of a hammer mill. Rotor speed is nothing but the speed of rotation of the hammers, and feed rate is at what rate you are inserting the material into the milling chamber, and clearance between hammers is nothing but the distance between the head of a hammer to the side wall of the milling chamber. And milling chamber side walls are called as grind plates. So the distance between these two are nothing but the clearance, and the number and type of hammers, how many hammers are available within the rotor, and what size of screen you are putting, the filter you are putting. This decides the product from hammer mill. And here you can see a small working video of hammer mill. This is an animated video of hammer mill where you can see the feed as well as the product and how the hammers are hitting it. This is typically a hammer mill, a smaller hammer mill which is used in industries. So this is the milling chamber. You can find it is open and the hopper is on the cover lid, and this is the hopper and this is the feed inlet, and there will be controller at the other end. And this is the milling chamber with 3 hammers over here. These hammers are like free to move swing type of hammers, and this surface is called as grinding plate, and the bottom you can see the sieve, and through the sieve, from the sieve there is a pipe connected for the product outlet. And these are various types of sieves used in a hammer mill. So there are various aperture sizes, very coarse to very fine, and the screens are of various shapes, as we can see here. This is another important area that we should understand. It is not only the screen aperture size that decides the output particles and their sizes. Actually, the speed of machine, how does it control the particle size of the product, is being shown here. You can see the picture A as well as the picture B. It shows A shows the effect of speed and B shows the effect of thickness of the screen. It is not only the aperture size, but the thickness of the screen is also a matter in size reduction. So it clearly represents, if this machine is running in a slow speed, the particles will be falling almost in a vertical direction, and that allows the entire big particle to come out through the mesh. Whereas in high speed, a straight fall of the particles will not be there, it will be coming in a tangential direction. That allows only a smaller particles to come out. And see the picture B. Here the thickness of the screen is affecting the particle size output. Again, as if the speed is constant without adjusting, if the screen was thin in the first 2 lines, if you consider the screen was thin, a bigger particle would have come out. But as the thickness of the screen increases, let how big the aperture be, only a small particle can come out. So that is being shown in the picture B. Now, what are the uses of this hammer mill? Hammer mill is used for fine to moderate grinding of particles 10 to 400 micrometer particle sizes, and non-abrasive to moderately abrasive substances can be size reduced here. Brittle materials can be powdered, and dry materials, wet, filter press cakes, ointments, slurries, etc. also can be size reduced by using special techniques in this.